How to Factor Binomials, Part 2 on Aiken's How To Math. So in Part 2, we're going to continue on with factoring some binomials. Just like every time they ask you to factor something, look for the greatest common factor first. So looking at these two terms, they have no numbers in common and they have no letters in common. So that means I need to go over these rules or try to use these rules for factoring a binomial. First, I need to see if it's one that can be factored. Minus sign in between the two terms. I've got two numbers here. I need to check and see if these two numbers are perfect squares. I can take the square root of 9 and I can take the square root of 4. I also need to check my exponents and make sure they're even, which they are. So everything is checking out. Looks like I can factor this. Since I can factor this like a binomial, the first thing I need to do is make two sets of parentheses. So let's do that. Let's make two sets of parentheses. First thing I'm going to do is start here in the front. I'm going to take the square root of 4. Square root of 4 is 2. So in the front of these parentheses, I'm going to put a 2. Then, since this is an even exponent, I can split this variable up. That means I can put 1x in the first set of parentheses and 1x in the second set of parentheses. Then I go to the number in the back here. It's a perfect square. The square root of 9 is 3. So I put a 3 right there, 3 right there in the back of the parentheses. In one set of parentheses, I put a plus sign. In the other set of parentheses, I put a minus sign. So here we have another example similar to the one before. Again, when somebody asks you to factor something, the very first thing you're supposed to look for is the greatest common factor. There's no common number that will go into 16 and 25. They don't have any letters in common. So I'm going to see if it's a binomial that can be factored. First thing I need to check is the sign. This right here better be a minus sign. It is. The coefficients, the numbers they give you right here, they better have square roots. They better be perfect squares. 16 has a square root, it's 4. 25 has a square root, it's 5. And exponents have to be even. So everything is working out, so we're going to use the procedure for factoring a binomial that can be factored. I'm going to make two sets of parentheses. I'm going to take the square root of this number right here in the front. Square root of 16 is 4. So right there in the front of those parentheses, I'm going to put a 4. This exponent has to be even because I'm going to split it up evenly. Put 1x beside the 4, 1x beside that 4. I'm going to go to the back. I'm going to take the square root of this number. Square root of that number is 5. Put a 5 in the back. In one of them, I'm going to put a plus. The other one, I'm going to put a minus sign. Now that we've got the basics of these, we need to start thinking about what students have problems with when they start to do these. Because right now, you just simply follow the procedure and it'll help you factor it. What they forget is I've got two binomials right here. I need, at this point, to start checking if these binomials can be split apart. For example, this binomial right here, I'm going to see if I can split it apart like I split this one apart. Well, I can't. It's got a plus sign. Well, maybe I can with this one. This one's got a minus sign, and I can take the square root of 4, but there are two problems with splitting this one up. I can't take the square root of 5. What we're going to start encountering is some of these binomials can be factored again, and that's one thing that can make factoring binomials difficult for students. So here's an example of a binomial that can be factored more than once. Again, when we go to factor something, always look for the greatest common factor first. There's no greatest common factor. Check and make sure it's a binomial that can be factored. Minus sign, I can take the square root of this number, and I've got an even exponent. So we're going to go through our procedure of factoring this binomial by making two sets of parentheses. Right here in the front, I have x to the 4th power. Remember, this has to be an even exponent. Since it's an even exponent, I can split this up evenly. That means I'm going to have x squared and x squared in the front. I take the square root of this number in the back. The square root of 16 is 4. I put that 4 in the back of each one of these sets of parentheses. In one set of parentheses, I put a plus sign. The other set of parentheses, I put the minus sign. I now need to check and see if either one of these binomials can be factored again. So let's look at this one. One of the things for it to be factored, it has to have a minus sign. So this one can't be factored, but this one has a minus sign. I can take the square root of 4, and there's an even exponent. So this part right here can be factored again, just like we factored this one. What you do is you bring this binomial down, x squared plus 4 in those parentheses, because this one can't be factored. And I'm going to split this one into two sets of parentheses. Just like before, x squared, I'm going to split that up evenly, put an x here, an x here. I'm going to take the square root of 4, which is 2, put it in the back. In one of them, I'm going to put a plus sign. The other one, I'm going to put a minus sign. I need to see if any of these can be factored again. This one has a plus sign, this one has a plus sign, but this one has a minus sign. Maybe this one can be factored again. The problem is I can't take the square root of 2. So what I've done is I've factored this completely. I always need to check these binomials once you split this up and see if those binomials can be split up again. The final answer looks like this. This is factored completely. X to the 4th power minus 16 factored completely looks like this right here. So always check the greatest common factor first. Every binomial you split something up into, check those binomials and make sure that those binomials can't be factored again. Our final example, we're going to take everything we've learned so far and put it all in one problem. Remember, the very first thing you're supposed to check is the greatest common factor. And this one looks like it's got a greatest common factor. We've got 2 will go into both of these numbers, and they both have an x in common. So my very first thing I'm going to do is I'm going to factor out the greatest common factor. 2 will go into both of them. X is in common as well. I put that on the outside of the parentheses. How do I get what goes inside the parentheses? I divide each one of these terms by this greatest common factor. 2x to the 5th power divided by 2x. I have x to the 4th power left over. Minus 162 divided by 2, 81, and x divided by x means there's no x's left over. Now that I've factored the greatest common factor, I have a binomial inside here. Well, I need to see if it's one of the binomials I can factor. It's got to have a minus sign, which it does. I can take the square root of 81, and this is an even exponent. So what I do is I bring down my greatest common factor. It's still on the outside. I make two sets of parentheses and go through my procedure of factoring this. Split this x to the 4th power up and put it in the front. Split it into x squared and x squared. I'm going to take the square root of 81, put it in the back. Square root of 81 is 9. I put a 9 here, a 9 here. One of them needs a plus sign, the other one needs a minus sign. Remember, I need to factor every binomial that can be factored. This one can't be factored, it's got a plus sign. But this one has a minus sign. I can take the square root of 9, and there's an even exponent. This binomial down here on the end can be factored again. So what I need to do is I need to bring down my greatest common factor again, this binomial that can't be factored, and I'm going to split this binomial into two sets of parentheses following our procedure. Our procedure tells us I need to split this up. Since it's x squared, I can put 1x here, 1x here. I can take the square root of 9, which is 3, put that in the back. One of them needs a plus sign, the other one needs a minus sign. So let's check. This one has a plus sign, can't be factored. Plus sign can't be factored. This one has a minus sign, but I can't take the square root of 3. This problem has been completely factored. Here's what my final answer looks like. This is taking everything that we've done so far. Greatest common factor and factoring binomials.